Okay, so here is something that happens more than you would think. You buy something online, you tap pay. The page just spins. Your Wi Fi hiccups for a second. So you tap pay again. And later, you check your statement and you have been charged twice. Whose fault is that? Your internet? The app? The answer is more interesting than either one. And by the end of this, you will know exactly how it happens and the one small fix that stops it. But first, a more basic question because everyone in software says this phrase all day, just call the API. But if I stop you and ask what is an API, most people freeze. It's a URL, you hit it, you get the data back. And that's the thing I want to fix because an API is not a URL you hit. An API is a contract, an agreement between two systems about what you can ask, in what shape, and what you are promised back. And once you see it as a contract, a whole pile of confusing stuff clicks. Why that pay button double charges? Why you cannot just rename a field? Why calling an AI turns out to be an ordinary API call? Let's build it up properly. So, at high level, what is an API? Let's not start with code. Let's start with a restaurant. You sit down, someone hands you a menu, a fixed list of the dishes you can order. You don't walk into the kitchen. You don't tell the chef how to cook. You speak only through the menu. And that menu, that's the API, the list of things the system will do for you. And the exact way you have to ask one item on the menu. One thing you can ask for is called an endpoint. So for our shop, post slash orders, place an order. That's one endpoint. The little packet of what you want is the request. What comes back, your dish, or the data is the response. And sorry, we are out of that. That's an error response. Same channel, still an answer. And here is what makes this so useful because you only ever talk through the menu. The kitchen can change completely behind it. Rewrite the recipes, swap the whole kitchen, and as long as the menu still means the same thing, you never notice. That's the point of an API. It lets two whole systems work independently. One owns the kitchen and the other just reads the menu. So, an API is a URL, isn't quite right. A URL is where one endpoint lives. The API is the whole menu. Every call, every shape, every promise. It's not an address, it's the rule book. The API is the menu, not the kitchen. You talk to the menu, and the menu is a contract. Okay, so we have endpoints. One obvious way to design them, one URL per action, slash get order, slash create order, slash delete order, and on and on. You can feel it already, right? Every new thing you can do is a brand new URL. It sprawls. So the common style, you will see it everywhere. It's called REST. It's cleaner. Now, REST is a bigger bundle of ideas that we need today. But the one piece you will use every day is this. Put the thing in the URL and let the method say what to do to it. The URL is a noun slash orders slash 123. That's order 123. The method, the verb from the last video, is the action. So on one order, order slash 123, get reads it, put replaces it, patch edits a part of it, delete removes it. And to make a new order, you don't get to pick its ID. You post to the collection slash orders, and the server hands you back a fresh one. Same nouns, different verbs. The method does the work. And here is a quick tell of a rough API. A URL like slash get order is trying to be a verb, duplicating the method that's already sitting right there. Rule of thumb, URL is a noun, method is a verb, and each call answers with a status code. 201 created, 200 OK, 404 not found, little numbers that say how it went. The URL is a noun, the method is the verb. That's your whole set of actions from one clean address. Okay, now we solve that double charge. And this is my favorite part because one property explains the whole thing. Two requests get slash orders slash 123. Read the order, fire it 1,000 times. Nothing changes. It's all read only. We call that safe. Refresh all you want. Some requests do change things, but you can still repeat them safely. Put slash orders 123, set order 123 to exactly this. Do it 10 times. The order ends up exactly as if we did it once. We call that idempotent. Get, put, delete, all idempotent. But post is the odd one out. Post slash charges. Charge this card 5980. Do it twice, you get two charges. Not safe, not idempotent. And the real difference between post and put is intent. Put says make it be this. Run it again, same result. Post says do this action. Run it again, it does the same action again. The create versus update rhyme people memorize is just a side effect of that. And here is where it bites. You send post slash charges, the server does the charge, and right before success comes back, the network drops. Now you are stuck. Did it go through or not? You honestly cannot tell. Retry, and if it had succeeded, you just charge it twice. That's the bug from the intro. The dropped connection makes the ambiguity. Nobody's fault, networks do that. Turning it into a second charge, that part is on the API. A post with nothing protecting it. So, how do you fix it? You make the post repeatable on purpose. The client makes up one unique tag for this one, checkout, an idempotent key, and sends it in a header. Every retry of that checkout carries the same key. The first time the server sees that key, it charges and remembers it. Sees it again, it doesn't charge. It just replays the answer it already gave. Same key, one charge. This is exactly what Stripe lets clients do on payment requests. And quick, idempotent is about the same effect on the world, not the identical answer. Delete twice, the second say is already gone. Different answer, but the order's just as deleted. Some requests you can safely retry. Get, put, delete. One you cannot is post, unless you hand it a key. That key is one of the protections that stop your bank charging you twice every time your Wi Fi blinks. Okay, quick step back because something just shifted. We have built the big idea. An API is a contract, and everything left in this video is really one job protecting that contract. We just did the first kind. Idempotency protects it when the connection drops. Three more to go. Keeping it alive over time, controlling who can use it, and holding it under load. Let's take them one at a time. First, over time, the contract is the agreed shape. For each call, what you send, what you get back. Read order 123 and you are promised an ID, an item, a quantity, a total in cents. And you can write that whole shape down in the plain file. So both teams, even the machines, know exactly what every call looks like without reading any code. The contract is a real checkable document. And because the shape is published, the team can rebuild everything behind it and you never notice. That's the promise. But it costs both ways. They cannot freely change the shape anymore. Say a developer thinks total underscore cents is an ugly name. Let me rename it to amount. Feels harmless, right? It's their own code. But every app out there reading the total underscore cents now reads nothing. The field is just gone. So, this is the line I want to land. A rename is a removal. You removed one field and added another. And a removal breaks everyone who was depending on it. This is straight out of Google's own API design rules. A rename is treated as remove and add, a breaking change. Adding a field though is usually fine. Old apps just ignore what they don't recognize. So the rule is simple. Add carefully. Never remove or rename. And when you truly must break the shape, maybe a big redesign, you don't edit the contract under everyone's feet. You publish a new one beside the old one. That's versioning. Slash V1 and later slash V2. Old apps stay on V1. New apps opt into V2. Both run at once. The moment a contract is published, it's not yours to change on a whim. Add, never remove. And to break it, ship a new version. That one discipline is why a client written 5 years ago still works today. Okay, next. Controlling who gets to use it. This shop API is on the open internet. The server has never met you. So it asks two questions. And hear them as two. Who are you and what are you allowed to do? Proving who you are is authentication. Checking what you may do is authorization. Auth N and auth Z. And HTTP has a code for each. No proof of who you are, 401. The name says unauthorized, but it really means unauthenticated. I don't know you, go log in. That's a stranger at the door from the last video. Next, 403, forbidden, is different. I know exactly who you are, and the answer is still no. You try to delete someone else's order, the server knows you. It just says not yours. The known guest, one locked room, so 401. I don't know you. 403, I know you and still no. So, how do you prove who you are? You send a secret with the request. The simplest is an API key, a secret that says which app is calling. And it's a bearer secret. Whoever holds a valid one is treated as you. The server checks it's real, but asks for nothing else on top. So, if it leaks, someone else is you. You guard it like a password. Which is exactly why where it goes matters. The key writes in a header, authorization bearer. Then the key, not in the URL. Because the URL leaks into browser history, referrer links, routine logs. Header doesn't get copied around like that. So, secrets go in headers, never in the URL. Who are you? Authentication 401 if you cannot answer. What may you do? Authorization 403 if it's a no. Two different questions, two codes. And the key that answers the first leaves in a header, never the address bar. Last one, holding it up under load. The API is public, anyone can call it. So, what stops one runaway script from hammering it a million times a second? A rate limit, a cap on how many calls you get in a window. Go over it, you get 4 to 9 too many requests. Plus a retry after, come back in 2 seconds. Now, this rhymes with last video's queue, but it's not the same tool. The queue buffered work and made it wait. A rate limiter just refuses the extra and tells you to come back. Same problem, finite capacity, blunter answer. And a cousin you will meet on day one. Ask for all the orders, and there is a million of them. And the API hands you a page at a time. That's pagination. Its own little topic, just meet the word. And one last thing that trips up even veterans. You make a call, you get 200 okay, green, done, right? 200 really does mean success, but success of the call, not on the thing you wanted. You can get a clean 200 whose body says status declined, insufficient funds. And call worked perfectly. The payment is dead. So the status code is the category. Did it go through? The body is the result. What actually happened? Under load, a rate limit at the door and everywhere. Read the whole answer, not just the status line. The status tells you the category, the body tells you what actually happened. Okay, we have built the whole toolkit. Let's point it at the thing everyone treats as magic. What happens when an app calls an AI? Surely there is some special AI machinery in there? There isn't. Watch. Calling a big language model, say OpenAI's, is a post to an endpoint slash v1 slash responses, an ordinary endpoint like slash orders. And the request body is basically two fields model, which model to run, and input, what you want to say to it. That's the contract, a name and shape of input. Two systems agreed on. And everything else you already know. Prove who you are, a bearer key in the authorization header. Leak it, someone spends your money. What comes back? JSON. You read the model's reply out of an output field. Call it too much, 429. Same as everything else. So that's it. An endpoint, JSON in, JSON out. A key in a header, a rate limit. Every piece of that you learned in the last 15 minutes on a shop. The model behind it is complicated, deeply complicated. The request is not. It's the same contract you already know, pointed at a model instead of an order. The AI isn't a different kind of thing you talk to. It's the same contract you already understand. You are just asking a model instead of database. Okay, let's pull all the way back. We started with a double charge and a phrase nobody could define, and we landed the answer. An API is a contract, and everything after that was that one idea. Protected four ways: rest, nouns, and verbs. Names it cleanly. Idempotency, safe to retry. Protects it when the connection drops. Versioning, add, never rename. Keeps it alive over time. Auth, who are you? What may you do? Controls who gets in. Rate limit, hold it up under load. One contract, four ways to keep safe. And then we pointed the whole thing at an AI call and it just dissolved. No magic, same contract. So here is the one thing I want you to keep. Next time someone says just call the API, you will hear what they are really saying. Not hit a URL. Honor the contract. What can I ask? In what shape? And what am I promised back? An API was never a URL. It was always a contract two systems agree on. And this is where the whole series turns a corner. For 6 videos now, we have followed one request where it goes, who it asks, whether we can trust it, what it's really saying, what it costs, and now the contract it obeys. From here on, we stop following one request and we start asking what happens when a million of them arrive at once. That's where the system design really begins. So, if you want to keep pulling this thread with me, subscribe, and I will see you in the next one.